All right. Shh. Yeah, we're gonna talk about kinematic today. Your test tomorrow. I heard you guys have a lot of tests tomorrow. Today? Do you have tests tomorrow? I think only sophomore. Yeah, that's good.
You have a test tomorrow. Do we have a test tomorrow?
All right. Shh. So we're gonna talk about one last question. You are expected to have cone, sphere, cube, shadow, ladder, ships, and the kinematic and the angle changing. So all those questions, I think the angle changing is probably the the things that you probably need to go back to focus a little bit more. Cone is more recently. Sphere is first day. Yes. I don't think so.
Is it one question per topic?
Yeah.
So it's cones, cube, ladder, shadow.
Everything's over there on the small handwriting. All right. So yes. So we're gonna continue to talk about other things. Which is kinematic. Usually should be within 30 minutes. You should learn more than you learn all year in physics. The bars are real low. You learn more about summering, right?
What?
You learn more about summering.
Honestly, yeah, I don't even know what he talks about at this point. He didn't talk about anything.
Or banana tree.
He talked about the banana tree.
It fell down during the
It fell down during the hurricane.
He's honestly typing it up.
7 of my minutes.
He was talking before. It's like, wait, banana tree.
All right, so so what we're gonna talk about? Yesterday, did we show you a video or no? Of a vacuum feather versus bowling ball. So first thing is the first stage is understand a little bit of gravity. Gravity, obviously, what's the difference between weight and mass? I forgot. Oh, I know what the weight and mass. Yeah, so yeah. Okay, so if you have bowling ball and a baseball, it's gonna fall at the same time. If you have bowling ball and feather, it's gonna fall at the same time in vacuum because of air resistance. So those are things that you need to understand. Brandon, thank you. Thank you. All right, so in your physics class, you should learn following things. You should learn start by free fall. What is a free fall? Free fall is, oh, first of all, what is gravitation constant? Did we talk about that yesterday? Okay, so it's 9.8 meter per second square. Pay attention to unit because unit does help you. That's in physics. But in math, which is i.e. calculus here, I'm gonna use this is negative, by the way. G is equal to negative 32 feet per second square. Make sure you understand the units because a lot of time units can give you a clue. Now, there's a reason why I use 32 because 32 is easy factorable. Not like I prefer imperial system over matrix system. I prefer matrix over imperial. However, in calculus, I feel like it's much easier to work with the problem. It's factorable, it's things like that. Now physics does change it to 10. 10 is somewhat factorable, but factorable between 5 and 10. But 32 can factorable to between 2, 4, 8, and 16. So those are a lot more easy to factorable. Yes.
So are the physics one okay to use on if we interchange it? So if we are doing in meters, we can use the 9.8, or does it have to be, if we're doing it math related, it has to be a -32?
In my class goes, I'm gonna use feet per second for the projectile. Now sometimes on AP exam question will write meter per second, so they will give you a different equation. So I will show you that in calculus book. They also show you 2 different version of questions. So I will show you which 2 version of it. In general, this free fall. So we're gonna talk about free fall first. Free fall, that means I take something, I look at me, if I take something, I just let it go without exerting force down or insert a force up. I'm just take this and I'm gonna widen my finger, I'm gonna drop. So that's called free fall. A free fall situation is always the same. Doesn't matter here or in China or Japan, doesn't matter. Okay, so the ball is gonna land on the ground. Now free fall is gonna have this equation. So S of t in terms of free fall, it's gonna be half gt squared. And in physics, you probably see this. In physics, you always might see this too, which is half times 9.8 t squared, which is negative 4.9 t squared. So you couldn't probably see negative 4.9 t squared or negative 5 t squared. And that's the free fall. Now in the calculus, I'm gonna use the same thing, which is S of t equal to 1/2 gt squared. So this is a free fall is a half times 32 t squared. So that's equal to negative 16 t squared. So I prefer use this just because that's a nice number rather than negative 4.9. Negative 16 t squared, that's going to represent how far they fall. Yes.
Is it negative because it's like falling out?
Yes. So let's talk about why it's negative. Acceleration and velocity has a vector, has a direction, right? If I say acceleration, in this case, you can go, acceleration is always pointing downwards in the earth. And that's why we stay on the ground, we're not floating. Okay? So acceleration is the same as a gravity in the earth situation. In the earth situation, that we're gonna prove to you they are the same. So why that's not negative 32, is negative 16? There was a reason for that. Because if I take a second derivative, I'm gonna get acceleration. That's gonna end up to be negative 32. But that is the understanding that acceleration has a negative vector because it's going down. Now, velocity, if I throw a ball upward, I have a positive vector. We're going to talk about that later. But right now, we're just talking about dropping something. So remember yesterday I told you that if I kick a fat person out of edge and a skinny person out of edge, you're going to fall at the same time. I'm just giving an exaggerated situation so you can picture that, but don't do that realistically. Not making any threats. Conduct, code of conduct, Mr. The idea is to understand, just like the baseball and volleyball situation, it's gonna fall at the exact same time. Even you feel like volleyball is gonna fall faster, whatever you feel like, it might not intuitive. You probably still feel like that. Even I would tell you that this is true, they're gonna fall at the same time, but inside my heart, I still feel like the heavier object is gonna fall just slightly faster, maybe. But still, the experiment probably more likely to be almost the same. There's a little bit of negligible. Okay, so what does this mean? Negative 16 t squared. I remember there's a movie to Journey to the Center of Earth. Have you guys seen that movie before?
What movie?
Journey to the Center of Earth before? So basically, they were traveling inside the Earth, and they went to inside a cave, and they trying to discover this new world that inside the Earth. But you know, it's fiction, so they make up anything. So basically, they went on this cliff, and this cliff has, let's say, we don't know how long is this question mark, and they only have 400 feet of ropes, and they don't know how deep is this cliff. So in the movie, the guy decided to tie a glowing stick with something like will create loud noise. So because it's a pitch black, so that's why they use the glowing stick. But they find out it's so deep like they can barely see the glowing stick. So so they put like a belt on it or something, so to make it a ring. Like when you hit the ground, at least a ring. So basically, the person's gonna drop something and count how many seconds fall on the ground. And basically, they use this equation. So you probably need to know this equation one day you go to skydiving.
See the ground.
You have to know how many seconds later you had to press the parachute. If you calculate wrong, then guess what? You screw. Okay. So in terms of scale, I'm going to show you in terms of scale. So T and S of T. So I can use H of T or S of T. I like to use the S of T because I know that's position. So if I plug in 0, I'm going to fall 0 feet. If I plug in 1, I'm going to fall 16 feet. Is that okay? What happens if you plug in 2? What is it? You better know how to plug in numbers. 2 squared is what? 4 times 16. So order operation 2 is going to square first. So that's going to be negative 64. At 3 seconds, it's going to fall roughly negative 144 feet. At 4 seconds, it's going to fall 256 feet. At 5 seconds, it's going to be 400 feet. So if you have 400 feet of rope, it's enough for 5 seconds. Not 5.1, but 5 seconds. Okay, 5 seconds, then you say, oh, that's 400 feet. Okay, I have enough ropes if I have 400 feet. Now, if 6 seconds, that's going to grow really fast. Now, in terms of scale, I want you to see each of those graphing paper grids is going to represent 16. So in 1 second, this is going to be how far I fall in terms of scale. In terms of 2 seconds, it's going to fall 3 times more because it's going to be 48 feet plus 16 feet, 64 feet. It's 2 seconds. So it's going to fall even faster. You see that ratio is 1, 3. Next one's probably going to be like 5. Oh, sorry, that's not 5 seconds. This is 3 seconds. And next one should be 7. So this is how far they fall, but each space is represents 16 feet. So you see that the object is gonna fall faster as the time goes on, and gonna cover more distance as time goes on. Everybody know that, right? So we can say the free fall is 1/2 gt squared, and g is 32, so therefore it's negative 16t squared. What'd you say?
Is it just adding 2 every time?
Yeah, the space is adding 2, but it's actually but you have to take account whatever you fall before too, right? So yes, adding 2 each time because it's square. So they have a second difference. And last year we do the first difference and second difference. There's a second difference. The second difference is gonna be like it's always gonna be the same. So that's gonna be negative 16t squared. And you say, oh, okay, that's cool. But in physics, we don't only study free fall. For example, how many of you guys play golf? Liam play golf. Okay, good. And Kadian play golf, right? So, and there's other people play different sports, but they all have something to do with gravity one way or another. So what happened is, if you realize like something impactful, like just say golf ball, right? It's very interesting when the club hit the golf ball, at that instant, the golf ball stay away from the club. You have no longer have control of that ball. Does that make sense? The ball is just flying. The only thing control is the angle you hit. What else? The wind? Gravity? Which is mainly
Speed that you hit it at.
yep, initial velocity. That's the wind, right? Or maybe spin. I don't know. The spin factor? How long it stay in the air? It does. Probably a little bit, very minor. But yeah, so there was a lot of factor into when you're hitting a ball. But what if you hit a ball on top of the mountain, right? And you're gonna land on the ground, that'll be a little bit different too, because your initial position is different. So there's a little bit different element in there. So in terms of projectile, that there is a S of t is equal to half gt squared, which is this part is free fall. I'm gonna add it to something because Liam is gonna hit a golf ball. It's gonna make an impact, and that impact of things of the club hitting the golf ball is gonna create something called initial velocity. So here it's gonna be a initial velocity times time. Does that make sense? Initial velocity times time.
What's that little circle in that?
That's initial, V0. So this is how fast the golf ball stay away from the club. Now, if you ever watch Mark Ruby video, there's a video talking about how fast they measure the speed when the kicker kick the soccer, not football. The kicker kick the soccer ball. So they measure the small distance and they see how much is no distance and they see how much frame per second they move. You can calculate the speed of initial impact. In 0.1 second, which is, I don't know, in terms of video, it's 32 frames per second. So if you just see one frame, it's divided by 32, or 30 frames per second. You divide it by 30. And then you see how much, that's 1/30th of a second, right? And you see how much a distance they move in one frame movement. And then you can calculate that the distance changing over 1/30, which is 30 frames per second. So you can find out how fast something moves at that impact. Now in golf, there's a machine that does that, right? They can tell you how fast you hit a ball, right? I don't know. I never played golf in my life, so I'm not rich enough to play golf. I can play ping pong because that's cheap. I need to get a table. I can't afford to go into the golf club to play, right? But, and also take account it's which position you're heading at. Are you headed on top of the building? Are you headed on top of the mountain? So this is called initial position. So this is initial velocity. And this is initial height. S0. S0 is now S of t and the h of t can be interchanged. Sometimes I use both. I use h of t represent height, S of t represent position. So in this case, we only talk about 2 dimension. I think it's interchangeable. For me, I'd rather use S of t because I like to think about position changing rather than height changing. But that's what I prefer. But also that S of t, that if you think about all those things, that you have position, you have free fall, which is nothing I can control. Everything fall at exact same rate. Now, initial velocity depends on if I'm Kadian hit the ball or Liam hit the ball, right? I will assume Liam probably hit it faster than Kadian because Kadian's scrawny little Indian kid. I don't think he can hit as fast as Liam. Am I right or wrong? Oh, okay, all right. Because you do need a little bit mass to hit that ball, right? So Cadence 2, it doesn't have that leverage, I think. But so as a T, we're gonna talk about that. So how fast we hit a ball. So 3 elements. Free fall, it occurs to every object. Golf ball, basketball, anything. The initial velocity depends on if it's Kadian or Liam. Right. We don't know what the initial velocity. Well, we don't know where we're gonna hit it at. We're gonna hit on the top of the school building or second floor or first floor or just maybe at a normal height. So those are things that affect the projector equation. So those are three things that affect factor. Now, what happened is in calculus, we're gonna use negative 16t squared because we're gonna say half g is represents 32 feet per second. So plus v0t plus s0, and that will be the final things I'm gonna deal with. So now I can use some information I get, depends. What I got, I'm gonna put in this equation. Now, what happened is we're gonna go back and look at the test questions. This is gonna be exactly the same test questions. Now, don't be busy to take a picture because there is no need, because I'll probably send it to you later. But it's different number that you're gonna have to work with. Okay, different number you have to work with. Now, this question is this. Now, mostly likely, it doesn't matter what question I give it to you. By the way, the Earth gravity and Moon gravity, how much difference do you guys know? Not 1/3, 1/6. Good job. Natalie, you pay attention in Greenwald's class.
Not much you can pay attention to, honestly.
Besides banana tree.
I don't care about the banana tree.
I like Greenwald. Greenwald's nice to me, so. All right, so we're gonna write down a position functions here. Position function is gonna be s of t equal to negative 16t squared. But what's initial velocity here? 96t plus what's the initial position? 180. Now I'm gonna go back to is that okay for everybody? Now I'm gonna go back to talk about what other things mean, because I think somebody asked me earlier. I think Baden has asked me, what does V0 mean? V0 means initial velocity. S0 means initial position. S of t or h of t represents height or position at giving time. T, of course, stands for time in second. Right? And what else do we know? Okay, pretty much we know everything here. So now we're going to go back. We're going to look at say, oh, okay, well, let's go back. Okay, so now we're going to find velocity. How do we find velocity from position or from position function? Nizar?
I'm just thinking like we reunite, like we isolate from.
Yeah, but we don't have velocity yet. Do we have a formula? We don't yet. Can you find it? Yes, Bennett?
Is this 96T?
No. Because it's also gravity gonna come into effect.
Oh.
So what can I do? Yeah, you can try again.
Negative 16 t squared plus 96t.
No, but that's only talking about position without the initial positions. Anybody else? What do we learn in this class? Derivative. Okay, not only any type of derivative, we're not taking derivative of respect to x, but here we can take a derivative with respect to what? Time. We take a d to the dt. So d to the dt means you change because of velocity, right? Velocity is changing s over changing t, right? That's delta s over delta t. Does that make sense? So you take in derivative of the position, you get velocity. So that's velocity here. If you take a derivative, it's negative 32t plus 96. Because 180 is going to go 0, 96t becomes 96 because that's a 180 is a constant. One more thing. Hey, with that saying, can I find the acceleration? How do you find the acceleration? What's the unit for the acceleration? Meter per second square, right? So we have meter per second. What do I do, Bennett?
Negative 32.
Negative 32. Exactly like the gravitational constant. And that's why you place the negative 16 in position, because you take 2-second derivative, it's going to give you negative 32. So you can even say this one is equal to s prime of t. You can say s double prime of t equal to b prime of t is equal to a of t, because SVA, that's equal to negative 32 feet per second. Now, I'm going to ask Liam, because he played golf. I want to find the time when the ball reached maximum height. I'm going to ask you, at a maximum height, what happened to the ball? It's not going up anymore. And it's not going down either at that instant, right? So that means what? Somebody say something, raise your hand if you think you know. Yes, McKenna? Velocity is equal to 0. So to find the time when the ball reaches maximum height, it's actually not so hard, because as long as you find when velocity equal to 0. I'll do a demonstration. I don't know how much time I have. How much time I have? 12 minutes. I probably don't have enough time, but luckily I have everything prepared. So this is me, and Miss made that throw a marker.
You're gonna hit me.
So do you see that marker still on my hand? Right? Oh, by the way, it's 32 frames per second, or 30 frames per second. I think on iPhone videos, a slow motion camera might be 120 frames per second. Those of you guys in digital things should tell me better. I don't know what is it, but slow frame is different. So I can calculate the distance of that out of my hand. It's about like 2 centimeters over there. And I can see how much a frame per second. I can see, I can convert it to feet per second. But as that marker left my hand, even though my hand's still moving up, but I have no power to make that marker in any direction, any speed anymore. I have no bearing of that. So when it's go up, it's going to start going up. So you see the vector velocity is going up. But there's two vectors. The second vector is acceleration. Acceleration is dragging this marker down. So the initial velocity is going to go up, but acceleration still keep on pulling down until get into a certain moment, right? Something that is still going up. I'm still going up, right? And then it stay up there at a very peaceful state, right? It's still going up. At this moment right here, he's chilling up there, right? It's not moving up or not moving down. At that moment, the speed of that marker is equal to 0, which is velocity is equal to 0. Does that make sense? Now, it starts dropping faster and faster and faster and faster and faster until it hit the ground. Now, do you realize I have an initial height because I didn't throw it from the floor? I have some height about roughly 4 feet high. Okay, so my initial height is 4 feet. The marker left in my hand is my initial velocity. Does that make sense? Okay. So now we're going to speed run this. Find the time when the ball reached maximum height. What are you supposed to do here? Set the velocity equal to 0. Do we have velocity equation? But we're going to write that first. On AP exam, if you write that, you get a point. 1932t plus 96 equal to 0. 1932t equal to 96. Sorry. And then divided by 32. That t is equal to 3. 3 seconds. At least got this part right. At least got the first 2 part right. And understand the velocity. So sometimes they also says like find the particle at rest. That also means the same thing when velocity equal to 0. Particle at rest. So write down particle at rest. The particle at rest is velocity equal to 0. Because we have velocity equation. We have acceleration equation. We have position equation. How do we find the maximum height? Plug in what? Yep, plug in the 3. And that's going to be negative 16, 3 squared plus 96 times 3 plus 180. Now, God help you. I don't know if you know how to add and subtract because second period or third period have 6 people give me 6 different answers. And dude, that's going to count a point against you, but please learn how to add and subtract and multiply by tomorrow because you don't have a calculator. Welcome to CCP. I'm going to get canceled for this video. Donald Trump will cancel. Okay, so how do you find the instantaneous velocity? What do you think? Plug it 2 into where? Equation. Now, if you realize this equation not any type of velocity, this equation is actually instantaneous. So this velocity equation is instantaneous velocity. So I just plug in 2. So it'd be negative 32 times 2 plus 96, I think. And that's equal to 32 feet per second, which is at 2 seconds, the marker is still going up, right? Because at 3 seconds reach maximum height. At 2 seconds, it's still going up. So this should be positive. And then you say this, not only that, pay attention to the unit. This 324 feet, by the way, if you know how to add, I swear, everybody give me different answer. You can add, good job. Okay, what's the average velocity? Well, what's the difference between instantaneous velocity and average velocity? You have to understand that. And this one is everybody gonna get it wrong. Don't get it wrong. And I'll tell you why, because I'm gonna ask you in a second. Well, instantaneous velocity is like you're driving, right? And you got pulled over. And the police is gonna say, I use a laser gun to measure your speed. At that instant, you were driving 70 miles per hour. But you can say, before I was driving 0 because I was in the traffic. And you are trying to debate the average velocity versus instantaneous velocity. So, yes, so you have to know, well, how do you find average velocity? By the way, intuitively, what do you think? How do I find average velocity? What'd you say? Adding to final what? Yeah, but for which function? Don't listen to Armin. Armin, you are you. Okay.
like just the same the way that you found like instantaneous velocity.
Okay, so you'll plug into the velocity equation, right? Wrong. You're not supposed to plug in the velocity equation. Think about it. If you plug in velocity equation, you would get feet per second. If you divide it by time, you're gonna get feet per second squared. That becomes acceleration. So what you told me is finding average acceleration rather than average. So remember, average velocity is changing position over changing time. So it's S of B minus S of A over B minus A. So it's S of 3 minus S of 0 on 3 minus 0. Guess what tomorrow everybody's going to do is V of 3 minus V of 0. And every one of those is going to get marked wrong. Like you go skiing, like you say, you know, you're going down, it's like, don't fall, don't fall, don't fall, don't hit the tree, don't hit the tree. And you know what? Tomorrow, all you guys gonna hit a tree. I will tell you don't do it, but tomorrow it's gonna everybody's average velocity. Oh yeah, that's just changing the velocity over changing time. That's wrong. That's average acceleration. So this one is end up to be 324 minus 180 over 3. So that's equal to 48 feet per second. The average velocity is actually greater than 2 seconds. Now, I want to find a time when they reach the ground level. How do I find a time when they reach ground level? Now, this one don't need a calculus, by the way. Just algebra. Caden?
Set ST equals 0.
Because ST equal to 0. Good, because that is the positions at 0. So we're going to say 0 equal to negative 16t squared plus 96t plus 180. And guess what? But tomorrow everybody's like, I'm going to use quadratic formula. Good luck with that, because tomorrow you don't have a calculator. And nearly, please learn Fox method. Because half of my BC calculus kids didn't remember how to factor on this question. And they use quadratic formula, end up spending 10 minutes to find out 96 square. You can't even add 3 plus 3 and you want to get 96 square? No. So, what you can do is factor out GCF, but always pay attention. The first one's negative, factor a negative sign. So factor out negative 4 here, that's the GCF, not negative 8, because 8 doesn't go to 180. This one's going to be 4t squared minus 96t minus, oh, not 96t, sorry, minus 24t minus what? 45, thank you. So now I can do this 4t squared. I'm going to teach you how to do Fox method. I'm going to be really nice. 2t times 2t equal to 4t squared. Good. What times what equal to 45? 15 and 3. Why 15? Because 9 and 5 doesn't work. Because 9 times 2 is 18. 5 times 2 is going to be end up 28. So think about it. If you do 9 times 5, that's going to be 18, 10. That's not going to give you 24. But if you do 15 and 3, that's going to give you 30t. That's going to be 60. Which one need to be negative? 2. So t equal to negative 3 over 2, t equal to 15 over 2. Now, you cannot go back in time unless you have DeLorean. I think that's a car call. From Back to the Future.
I know.
Okay, so, sorry, I'm a nerd. So now I can find out velocity impact. Guess what? You already find out the time take the impact. You can plug it back to velocity, which is 15 over 2. And whatever that is, 32 times 15 over 2. I think this is negative 96, right? I don't know what's a velocity equation.
I did all
You plug in both, or do you have to plug in
Huh?
you plug in both
Can you go back in time? Okay, good. Well, if you can, let me know. I would like to go buy a lottery ticket. Huh? This is terminal because that's when the ball hit the ground.
With that, what you should if you just drop something for like 3 hours, you will just keep getting speed, right?
Yeah, but a terminal velocity at an actual situation, you are gonna get a terminal velocity because the air resistance is gonna make you like at least you can only fall so fast.
A lot of exact, like not exactly, like similar questions to the test, or how's it gonna look?
I don't know.
Okay, so
You had to prepare all those things that I'm just go back to the cone sphere question, shadow question, see if you understand them, see if you can set up.
you covered more than Greenwald did in I think like 3 weeks.
I have a question. about
It's
this.
so sad.
It says for this problem that involves,
In the Wednesday period.
Yeah.
it says for this problem that the volume remains constant, and you're finding, I believe,
Wednesday.
you're finding it's a cylinder being squished, and I was lost. I was thinking. that you
Come
used
back
the-
after school. I have a next class to prepare. I haven't eaten lunch yet, so I'm not like I don't want to ignore you, but